Hello everyone, welcome again to Geospatial Tube. This is a turn to compute soil depths to assess landslide susceptibility mapping in my study area. In the previous video, I have covered many factors that is contribute for landslide susceptibility, and today I will give you special emphasis how to compute soil depths. Let's get started. First of all, we need to have soil data, and you can download this soil depths map from different data sources, but I would like to recommend you to use the ISRIC Soil Data Hub. Since this ISRIC Soil Data Hub is free to download any physical or chemical property of a soil, you can easily access and download on the base of your project. This is the site. I will put it on the description box to easily access the data. There are different parameters. For example, there is raster datasets for soil depths, for absolute depths to bedrock, test depths. For some of exchangeable bases, there is data for a chemical property like cation exchange capacity, pH, and the like. So you can easily download and use for any continent. For instance, there is for a continent Africa, Asia, Europe, and the like. So this site is very good to use it. Then let's get back to ArcGIS Pro and let me show you the whole process how to compute soil depths using ArcGIS Pro. Before that, I would like to recommend you to subscribe my YouTube channel, and if you have any question related to this soil depths mapping for landslide susceptibility, don't hesitate to ask and put your questions on comment box. Let's get started again. This is the national dataset of Ethiopia. Let's explore our dataset. The minimum depth for a green one is 1, and the maximum depth indicates that there is 175 centimeter. Then the first thing that we are going to do is let us have a look my study area. Then zoom to layer. This is the administrative unit that I have computer landslide susceptibility in the southern part of Ethiopia named Kaukosha. Then I need to extract out the soil depths on the basis of my administrative unit. Then go to geoprocessing. The geoprocessing wizard is available here, and there are different toolsets. Scroll down and select spatial analyst. From spatial analyst, I have the extraction toolset. From extraction, I would like to select extract by mask. The input dataset is the larger dataset of the soil depth map of or raster dataset of Ethiopia. Then click here and select soil depths. The input raster or feature masks data is the administrative boundary. In this case, the Woreda boundary. Then scroll down and select the Woreda boundary. The output raster name should be renamed, and you need to set your working directory. Let me write as soil depths for calculation. Extract area is inside the administrative unit, and extent is this number indicates that minimum and maximum extent of this administrative unit. Then automatically hit run to access the clipped data of soil depths. This is the dataset that I have clipped from the larger datasets. Once you have access the required dataset, let me remove the larger dataset because I am not interested to use it again. For better visualization, you can right click here, go to symbology, and you can select your color on the basis of your color preference, and it helps to visualize the minimum and the maximum values for the raster dataset. So this map indicates that the red color is the area with lower soil depth, while the deep blue color indicates the area with maximum soil depth. Let's get back again to the threshold table. This threshold table indicates that area with less than 20 centimeter soil depth is very low susceptible for landslide, where the reciprocal area with greater than 200 centimeter indicates that area is highly susceptible for landslide. On the basis of this, I would like to evaluate my dataset to reclassify the soil depths of my study area. Hence, the minimum depth for this area of interest is 86 and the maximum depth is 175 centimeter. It lays between 50 to 100 centimeter because 86 is found between 50 and 100, and the second range is found between 100 and 200 because 175 is found between 100 and 200. So on the basis of this threshold, my study area have only two categorical values. That means the area within the southern part of this administrative unit, the red one, indicates that 86 and 86 is found between 50 to 100. So this is class 1. And the second range is 175, that is found between 100 and 200 centimeter. Then I do have two classes. To perform that, let's get back again to ArcGIS Pro and let me remove a symbology, and let's get back again to geoprocessing. From geoprocessing, there is spatial analysis tool. From spatial analysis, let's scroll down to reclass. From reclass, double click on reclassify. So the input raster dataset that I have is the clips dataset of soil depths, and the reclass value is the value of each raster's class or each raster cell. Hit classify. The number of class that I have is 2 on the basis of the criteria. Then the class should be set into 2 instead of 5. Then let me provide a range. Then the first is 100 because 86 is found between 50 to 100. Then the maximum value for that class is 100. Then the next is you can leave by default or you can write 200. Then hit OK. Let's have a look the start and ending point. So 86 means 100 and 6 to 100 is class 1, and from 100 to 175 is class 2. Then you can give your output raster reclass soil depth. Then let's hit run. But in our case, class 1 means you should memorize that 1 means in this case moderately susceptible to landslide. So I do have 2 classes. The first class is moderate because it is found between 50 to 100. This is medium or moderate. The other is highly susceptible. So let us open the attribute table and let me put it for the upcoming sessions. So let me add field. Let me provide weight. So short integer. This is the format is numeric. Let me select numeric. Hit OK. Save it. Get back again to the attribute table. So 1 means moderate. Moderate is the value is 3 and the other is 4. So at the end of the day, when I compute the weighted overlay, I would like to use 3 and 4 because 3 indicates that moderate susceptible and 4 indicates that highly susceptible for landslide. Let's evaluate our data set. This the area with a green value is highly susceptible to landslide, or highly vulnerable for landslide, because the soil depth is greater than 100 and it ranges between 100 to 200, and one indicates that the area is very low or moderately susceptible. Generally speaking, this area is highly susceptible for landslide on the basis of soil depth. This is all about soil. I will come back again with other parameters. If you have any question, don't hesitate to ask.